Welcome. In this video we're going to learn how to do a future value of an annuity due. And an annuity due is a little different than what we've been doing because we've been talking about ordinary annuities, and the difference is ordinary annuities payments are made at the end of the year, and in an annuity due they're made at the start of a year. So we're going to start by working a problem. We'll do it in Excel, we'll lay it out on a timeline, and we'll work it another way, and you'll be able to see exactly what we're talking about. So we have this problem that says you want to set some money aside in an investment so you can start a business in 5 years. You plan to make 6 payments of $5,000 starting with a payment today. You make 5 additional payments at the start of each year through 5 years from today. Assuming you can earn 12% on your investment, what amount of money will you have 5 years from now? Okay, let's start by opening a cell in Excel, a function cell, and we'll get our formula here. We're going to do a future value because we want to know what this is worth in the future. So we'll select future value, and we're going to put in our rate, which it says here is 12%. So we'll put that in, and then we have two parts to this. The first part is we have the payment today and what that's going to be worth 6 years from today. So we're going to put in 6. And then, because this is not an annuity, this is a future value of a sum. Our sum for the first year is $5,000. That's what we're investing in year 1. So you can see it gives us the answer of $98.69 and we click OK, and we have that. Okay, so now we're going to calculate the second part of this, and again we're going to be doing a future value, only this time we have an annuity. So let's put in our rate. It's still 12%, and we still have 6 periods, and our payments are minus $5,000. Okay, so that's going to give us, I think this should be a 5 instead of a 6 because we already have one payment, so we can only go up to 5. And so now we have a figure of $31,764.24. So that's the other part of this. So if we add these two together, we should get what we'll have from the future value of an annuity due in 5 years, plus the future value of a sum due in 5 years, which is $41,633.35. So that's our total, and we'll work this out a little different way, and we can do it. Let's do it right here. The first thing we have is we have our future value of a sum. Okay, and I'll put it out here. So we have, if we look at our present value tables, we're going to do this with a present value table. So we need the future value of $1 at 12% in 6 years, which is 1.97382. Okay, 1.97382. And we're going to transfer that over to our table here. 1.97382, and the sum is $5,000. So we'll put that in and we'll multiply it in the next row. So we take our future value factor times our sum, and that gives us 98.68, and I think it's 11, but I don't know. So let's change this, format ourselves to 2 decimal places. Actually came out to 10, and that's just rounding. So it's a penny off of what we did before. And now we're going to take our future value, I cannot type today, future value of an annuity due. Okay, so we have to find a factor from our tables for an ordinary annuity, because we don't have a table in this set of tables for an annuity due. We do for a present value, but not for a future value. So we're going to use this one here. Okay, so we have ordinary annuity, and this is for 5 years at the end of the year. So we're going to use our 12% in 5 years and write that down or put it into your calculator, but remember it at 6.35285. Okay, we'll come back here and we'll put that in our little table. Our future value of an ordinary annuity that should be 2.285. And what I really wanted to do is I'm going to cut this and paste it down here, because what this is up here is the future, I don't want to confuse you, future value of an ordinary annuity. Well, I'll just abbreviate. Okay. Or what I can do is I can slide this out a little bit and make room so we can put in the full name here. Okay, so we have an annuity of 5 equal payments of $5,000. So that's our annuity. And if we take our factor and we multiply that times our annuity, we get $31,764.25, and then if we add these two, we get exactly what we did calculating it the other way. Okay, so what I want to do now is I want to get my pen, and I'll show you how this is laid out on a timeline. And just bear with me a second. Let's draw a timeline. How come my pen's not working again? Well, I didn't want to do that. Okay, I'm going to draw it right here. Okay, so we're going to put 0 for today. Go out 1 year, 2 years, 3 years, 4 years, 5 years, and then 6 years is going to be over here. Okay, and our rate was 12%. And so we're going to invest, starting in year 0 or today, $5,000 for each of the next 6 years. So it'll look something like this. Hopefully your writing is a little better than mine, but I think you get the idea. So what we're going to do is calculate the future value for each of these. So we want to know what that is. And let's see, I got to erase something here because I have 7 years and I should only have 6. Okay, 1, 2, 3, 4, 5, 6. We have 6 payments, so we can only go up to 6. Okay, so what we want to do is we want to future value that to year 6, and 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 that one to year 6, and that one to year 6. Now this is the one that we did that came out to the 986911. So this is our future value of a sum. So let's label it. This is a future value of a single sum. And these are the future value of an ordinary annuity. Okay, and so our factor for this part here was our future value factor was our 635,285, and we had times 5 payments. So that was our 31,764. $25. And our future value of a sum, we had $5,000. And our future value factor in this case was the 1.97382, which was 986910. It's not a very good 98. There we go. 986910. Well, let me erase this. I want you to be able to see it. Still not a very good 8, but I think you can follow the flow. Anyway, so if you add those two up, that's the same thing as we came out to. And the 6.3528 is the future value of an ordinary annuity factor. So let me get a different color. Choose a blue. That's this factor here. We use the future value of annuity factor. Okay, so that's it. We'll see you in the next slide.